Hello, and welcome to this video on multiplying polynomials. As always, like and subscribe if you find this video helpful. Be sure to check out the linked video on different ways of multiplying. I am going to go through one particular strategy for how we can conceptualize multiplying polynomials, but it might not be the strategy that your teacher is using in your class. So there's an additional resource video linked that can help you integrate the different methods together, and drop a comment or question below. Now, just so you know ahead of time, my neighbors upstairs are installing a new floor after we had a big flood. And so you might hear some noise at points. And also I'm expecting an important phone call about repairs to my own apartment. Normally I would have my cell phone silenced and in another room, but it's kind of different circumstances. So if you hear some dings, it just is stuff happening. Just ignore them. It's just all just background noise that we have going on today. So for this particular skill, we will be using an area model, and hang with me through the explanation, and I will link a video showing how this method relates to distribution, which is also called foiling. I'm going to link that towards the end of the video, because I think even if your teacher is using another method, the area model is a valuable way for you to conceptualize what we're doing with polynomials when we multiply them. So I think it's worth it to just kind of hang through the explanation, even if you end up wanting to click on the other video to see how this compares with what your teacher is doing. So the key idea is that the area of a rectangle is its base times its height. Okay, so that is the key idea. So if you picture a rectangle, okay, we have a rectangle here, and the rectangle has a base, okay, and that would be the length of the rectangle, and the rectangle has a height, okay, then the area of that rectangle would be the base times the height. Now, if you want to see this even more visual, okay, suppose you have a rectangle that is 4 going that way, and you've got 2 going that way. So your base is 4 and your height is 2, therefore your area will be 8. And if you look at this, oh, look at this, 1, 2, 3, 4, 5, 6, 7, 8, you can actually see it. So that's like super, super concrete. Like area of a rectangle is the base times the height. And then we have the more generic formula there. So the area is the base times the height. And a couple of vocab things to note here. If you've got the base times the height, and that is equal to the area, these are called the factors. Okay, so these are the things that are being multiplied together. And this is the product. And so when we're using the area model, what we're doing is we're going to take the things that we're multiplying, in this case, polynomials, and the polynomials are going to become the factors. And what we're looking for is the area. And we're just going to model that in the shape of a rectangle with the base times the height. Okay, so that's the key idea there that should relate this into geometry. It can also really make it concrete. Now, up to this point, we have done what's called distribution, and this relates to area as well. So if you're looking at this problem here, most of you would do it this way. You'd say, okay, I have to distribute that multiplication through the parentheses. So 2 times x is 2x, and 2 times 3 is 6, and you would just say that's 2x plus 6. Now, here's what that looks like on the area model. You would make maybe the 2 the height, and then you would put the x plus 3, and you could put like a little plus sign there with 3, like x plus 3, but we would assume that it's positive, okay? And then what we do with it is we picture this as 2 separate rectangles. So you've got one rectangle that has a height of 2 and a base of x. So base times height would be x times 2, or 2 times x, and that would give us 2x. And then you have a base of 3 and a height of 2, so 3 times 2 would be 6. And then you would add these two areas together. So you have to find the total area, it would be area of 2x plus an area of 6. Now, most of the time, we do not use an area model for distribution. Okay, not particularly useful. Just it creates a lot more writing than we probably need to do the problem. But it does work. So you can see your distribution as an area there. All right, so let's dive into the actual polynomials here. Now, in this lesson, I kind of debated this. We are going to focus on binomials. So I have 3 examples with binomials. So remember, a binomial is a polynomial that has 2 terms. And so if you look at the samples here, we have a binomial here and a binomial here and here and here. So these are all binomials, like 3x plus 5 has 2 terms. And the reason we're going to focus on that is because the vast majority of your polynomial multiplication is going to be multiplying binomials, okay? Now, this method works for other kinds of polynomials, but this is like your main focus. So this is like the kind of piece that you want to get really good at. So to do this, we are just going to expand on the idea of area. So we take one of these factors and we make it the base, and we take the other factor and we make it the height. Okay, and so for my base, I'm going to have x plus 3, and we'll split that into the x plus 3. And for my height, I'm going to have x plus 4. And now what we do is we find each individual area. So this top rectangle here happens to be a square, so it's x by x. So x times x gives me x squared. This rectangle here has a base of 3 and a height of x. You kind of have to look out here to find the height. And so the area would be base times height, or 3 times x, or 3x. This rectangle here has a height of 4 and a base of x. And so doing base times height, or we might say height times base, and basically we just want to multiply them together. That would give us 4 times x, or 4x. And this last rectangle has a base of 3 and a height of 4. And so 3 times 4 is 12. And remember, what we want, though, is the overall area. We want the area that would be represented by the big rectangle. Okay, that's like the total product. And so we're going to add all of these up. We're going to have x squared plus 4x plus 3x plus 12. And you'll notice that in the middle, we have some light terms. We have a 4x plus 3x, which is 7x. Now, typically, when I am doing these out, I do not write this step in. And the reason I don't typically write it in is because I can look at my rectangle there, and I can see that my x terms are on the diagonal, and they will virtually always be on the diagonal. Okay, and so for most of us, we just look at that and say 4x plus 3x is 7x, and we just go right to the answer, right? I won't do that for the first couple, but I'll do it for like the third one. So here's another one. So this one's a little bit more challenging. We just have some more challenging kinds of things going on. So we have 2x minus 3. So that's one. And it doesn't really matter which one is the base and which one is the height, because when we multiply, we know that base times height is the same as height times base. Okay, just like 2 times 4 is the same as 4 times 2. It's just like turning the rectangle on its side. Okay, so if you have a rectangle and you just turn it on its side, it still has the same area. Okay, so however you want to do this. So we can make this first one, we'll make the first one the height this time. So we'll do 2x minus 3 is the height, and we'll make the base the second one, so 3x plus 5. And again, we're just finding all of the little individual areas, all the little individual base times heights. So first rectangle up here is 2x times 3x, so 2 times 3 is 6, and x times x is x squared, so that'll be 6x squared. Next rectangle has a height of 2x and a width or base of 5, so 2x times 5 is 10x. Next one is 3x. So we have a base of 3x and a height of -3. And I know the negative, you might say, well, a rectangle can't have a height of -3, and that might really bother you. There is a way to model that with algebra tiles. So I'll try to link a video into the description box so you can see how that works with the algebra tiles. you can manage the negatives, but it doesn't change how this works. So we're going to do 3x times -3, which is going to give us -9x. And then the last rectangle has an area of -15. So we have a base of 5 and a height of -3. And again, you might be saying, well, like you can't have an area of -5 or -15. You can, there is a way to model that. Okay. I know if you're carpeting your apartment, which my apartment's going to get all new carpet. So awesome. It's not really awesome, but because it had a flood, but anyway, but like, we're not going to talk about like the, closet as an area of -15, but for the purposes of the area model, yes, this conceptually can work. So there's a way to model it. And again, we want the entire area here. So we're going to do 6x squared plus 10x minus 9x minus 15. And we see we have those like terms. So we have 10x minus 9x, which would give us 1x or just simply x. So if you don't like the 1 there, you don't have to write it. And there is the product. There's the total area. All right, last one, that is a binomial times a binomial. So make your base and your height however you want. So I'm going to do x minus 1 and 3x minus 4. And we just find all the little individual areas. So 3x times x is x squared. 3x times -1 is -3x. -4 times x is -4x, and negative times a negative, -4 times -1 is +4. And this is what I would normally do. I would just look at that and say, okay, those are my like terms. Those are the things I need to combine. So I'll have 3x squared, -4x plus -3x is -7x, and then a +4. So normally I would not write in that other step. And you're welcome to do that. Okay. So that's pretty much how the area model works, is we're picturing this as a base and a height, and we're going to find the product, which is the area. And what it does is it takes kind of this messy, complicated problem and turns it into 4 little problems, like really small problems, like 3x times x or x times -4. Okay. And that makes it a little bit more manageable than you think about, oh, I got to multiply this whole parenthesis by another parenthesis. Now, this works for all kinds of multiplication. So this is a binomial times a trinomial. And I think with the more complicated ones is where the area model really, really comes in handy. It works. It's a good mental model. It's very diverse. And if your teacher taught you foiling, which I'll mention in the linked video, there's nothing like wrong with that, but it is limited because the acronym only covers a certain number of things. The area model will work for all of your polynomial multiplication because the concept is the same. Is you have a base and you have a height, and you're going to find each individual area and then add them up to get the product. So we have here, we have 2x times x squared, which gives me 2x to the third. 2x times 2x would be 4x squared. 2x times -1 is -2x. And then we have another set of fairly simple multiplication. -3 times x squared is -3x squared. -3 times 2x is -6x. And -3 times -1 is +3. And what you should notice here is that your like terms, so the things that you can add and subtract, are together. Now, that doesn't happen 100% of the time because it really depends on the original form of what you were looking at, but it is very, very common. Okay, so you can see where I circled the x squareds and the x's. So the 2x to the third does not have anything we can add. -3x squared plus 4x squared, that would give me 1x squared. That's a plus sign. -6x minus 2x, or -6x plus -2x is -8x. And then we have the +3. And you do not need the 1 there if you don't want it. And I really like that. Now, please check out, well, let me click over to the next slide. So really, area model will work for all kinds of multiplication. And I mean, you could get some really awful things but the worst thing that can happen is that your rectangle would just get bigger, and if you needed to multiply something that looked like this, I mean, one, that's awful, okay? But you've got a structure and a method that's going to work, and it keeps all of your work organized. So your work does not sprawl out all over the page. So I mentioned that I am in favor of the area model, and I did not learn with an area model. I actually learned this myself doing it other ways, but the area model has some really specific advantages to it. So if your teacher is okay with you using it, if your teacher insists that you show it a different way, you've got to do what your teacher says. But if your teacher is okay with you using this model, here are some of the advantages to it. First of all, it's compact and structure. It doesn't take up a lot of space. The rectangle itself might get bigger, but it's not going to stretch out all the way across your page, okay, which some of the other methods do. It's got a very compact structure to it. You won't miss one of the multiplications. So when you're multiplying, there's a bunch of little multiplications that you have to do no matter how you structure the work. So for the one we just did, we had 6 different multiplication problems we had to do. With the area model, because you set up this rectangle, if you miss one of the multiplications, you would have an empty box. So you're not going to miss anything. Other strategies, you don't have it laid out in a grid. You might miss one of them and you don't even know that you've missed it. It places like terms near each other, often on the diagonals. Okay, so it's often on the diagonals. You can kind of see where I'm doing that. If you had a bigger rectangle, okay, you would see something similar where your like terms would be on those diagonals. So the things that you wanted to add. Now that is not a 100% guaranteed kind of thing. It really does have to do with the order of the original problem, but it's very common. And even if they're not on the diagonals, they'll be close by. Okay, they're not going to end up far away, where you've just got to scan the entire rectangle and be I wonder if there's stuff here. That's the same. They will be close together. And the big advantage to this is that it provides a model for future polynomial math. So after we do multiplication, we're going to move into factoring, and you can use the area model to definitely simplify your factoring. And then the real payoff will come in Algebra 2, because this model will also work for dividing your polynomials, which is really not fantastic any other way. It's extremely versatile. So if you can get good at multiplying this way, it's going to give you a mental map and a tool that will springboard you into future math. Now, I am aware that a lot of teachers will not do this method, and they might, you might have a teacher that's not even okay with you doing it. Okay, so you turn in your homework and you're doing the area model, and they're like, ah. So what I want you to do is check out the video linked in the corner. Okay, it should be linked up here somewhere, okay, somewhere in that corner. Click on that and to see how this method relates to other methods you may see, and I'll actually work them out side by side, and that can equip you to be able to be fluent, to maybe explain to your teacher, how does this work and why is this a better method for you? Or you'll be able to take what you learned in this lesson and transfer it over to another way of writing it. So be sure to check that out. Don't forget to like this video if you found it helpful, subscribe for more math content, drop a comment or question below to engage, and check out some of the other videos and playlists on the channel, including a video on how multiplication is modeled with the algebra tiles. So if you've seen some of my algebra tile videos where you have the different tiles here, you can actually model this with the tiles, and I will try to link that in the options that you have available to look at on this. So be sure to check that out, and also check out the practice set so you can practice these and check your answers. That'll be linked in the description box. So all right, I hope this was helpful, and I will see you in the next video.